Hello, good evening, everyone. Good evening, and welcome to our very first evening Cytrons webinar series.
Hi
Thanks for
everyone.
joining today. Hi. Hi, Ahmed. Okay, thanks for we are very glad to have you tonight.
Yeah,
And I hope all of you are having a good day so far, and we are gonna make it better in this 1 hour. We hope. And So welcome again to Cytron's webinar series. Normally we do this in the morning, 11 to 12. Today we are going to try something different. We are going to do it in the evening. And so here we are. I have Alhamed over here. He's Cytron's Technologies intern, and he's been very active in exploring on REKA. Okay, REKA is basically a microbit extension board. Means that it allows the microbit to do more. So if you don't know what is Rekabit, stay tuned. By the end of this session, we will also share with you on where you can get more information about Rekabit. Actually, Alhamed, he shared about Rekabit in his previous webinar series. So we are going
yeah.
to, he will be sharing you the link alright, on the later of this session. And of course, if you're here for the e-certificate, I hope you join in this session together with Ahmed to learn about how he's going to build an interactive robot using Rekabit and make code and microbit. Okay, so
Yeah.
I see some of familiar guys in the session here already, so that's very great. Right, thanks for supporting
Hi.
us from morning to evening. Very good. So Sihat is also here. It's like
Hi.
nice to
Good
see.
evening, everyone.
So yeah, we have a few people here. All right, without wasting more time, I'm going to pass the floor to Alhamed. He's going to go through the agenda for today, and yep, everything. Alhamed will be sharing it with you. Okay, Alhamed,
Okay. Yeah,
to you.
we are
Thanks.
ready. Yeah. Thank you so much, guys, for joining us today. I hope that you enjoy our today's webinar, and also I hope that you learn a lot. Okay. So before we start, actually, this webinar comes after the previous one. The previous one I talked about the REKA bit. Okay. I give a general idea about REKA, what is REKA, what can REKA do, okay, what's its features, okay, all this kind of stuff, Okay, so this webinar is following the previous one. Okay, and in this one we will focus more on how to deal with the sensors, okay, and how to deal with the DC motor, servo motor in details. Also, how to deal with the external LED, okay, with the REKA bit. So, if you want to have like a general idea, like an introduction about REKA bit, I would recommend to you to go and watch the previous one, okay. And also, I would like to remind you during this webinar, if you have any questions, okay, please don't hesitate to ask. Your questions are always welcome. Okay? So, without further ado, let's go through the agenda of today's webinar. Let's see what's the content of today's webinar. Firstly, we will have an overview on the interactive robot. Okay? We will build a robot using REKA. Okay? We will see how that robot work, what that robot can do. It's really cool, really awesome. You're gonna love it, guys. And then we will see what is the tools and the components that we will need in order to make that robot. Okay? After that, we will learn how to work with the external LED or REKA bit. And notice here I'm saying external LED because there is already we have like LED on REKA bit at the bottom here, okay? But this time we will learn how to deal with this kind LED, okay? So yeah, I will be showing you how to deal with it. And then we will also learn how to use the potentiometer, REKA bit, and we can do many cool stuff with it. So bear with me. After that, we will go through controlling DC and servo motor with REKA bit. And at the last slide, we will combine all what we learn, okay, and attach them or make them like connected to the sensors on microbit, okay, and build the robot together. So let's see how the interactive robot look like. Here it is. This is our interactive robot. Look nice, isn't it? So let me go through it one by one, explain to you how this robot work, okay? I will explain to you, give you a general idea. After this, I will show you how the robot work, okay? So by its name, like it's interactive robot, and that's mean this robot will react to the things that going around it, okay? So first thing we have it will react to the temperature, okay? So in this robot, we will set a temperature limit, okay? And if the temperature exceed that limit, the robot will show like different action, okay? First thing, it will change the green LED to the red one. It will be sad, okay? And its eyebrow, it will go down, okay? It will show a sad expression or angry, okay, because of the high temperature. And it also will produce a sad sound, okay? And also like this icon will be shown like it will be showing a sad expression, okay? This is once we come with the high temperature, okay? Other than this robot will react to the sound, okay? If we make like a high noise around the robot will sense that and it will move forward. For example, if we clap around the robot, the DC motor will move, which carry the wheels, and the robot will come forward to us. Okay? Other than this, also we will be dealing with the touch sensor. Over here, we have a touch sensor over the logo. Okay? If we touch the logo, it's like we are tickling the robot. So the robot will be happy. It will show us happy expression. The eyebrow will go up. The green LED will turn on, and it will produce a happy sound or laughing sound, okay? Same touch sensor, if we make a long press, long touch, it will show a sad expression, okay? So yeah, its eyebrow will go down, the red LED will turn on, and yeah, again, it will show a sad face on the icon over here, okay? I just mentioned to you like many sensors already: temperature sensor, sound sensor, touch sensor. Also, in this webinar, we will learn how to make or how to deal with the light sensor. Okay, and in this case, if we make like strong light on microbit, okay, the microbit can sense that, and the robot will move backward. Okay, the more and the strong light we have on microbit, the robot like will have like a distance from us. It will move backward. Okay, I will show you all that in a moment. Okay, I'm just giving you like a general idea about it. And other than this, we will control the sound of or the sound volume of the music. Okay, here if we click a button, like we will have music on the robot, and we can control the sound volume using the potentiometer over here in its nose. Okay, so this is basically the idea of the robot. If I am missing anything, it will be shown in the video. So let's have a look on the video. Okay, I already made the robot, and I record the video of its all sensor. Okay, and how does it work? So are you ready? Let's play the video and show you how the robot work. Okay, okay. Now I will start to show you how the touch sensor work. Okay, notice here if I touch the logo, the green LED will turn on, the eyebrow will go up, okay, and it will show happy sound just now, and the icon over here will change. See, it's happy now. And if we make a long press or long touch on the logo, it will show a sad expression. See, this is for the touch sensor. Now we have the temperature sensor. I already set the limit of the temperature to be 30, okay, and the temperature in the room is 31, so it's exceed the limit. So now the robot will sense that, and it will show like mad or sad expression. Notice here the temperature is high, okay, it shows a sad expression, and also it shows a temperature value over here, 31. Okay, now I'm trying to make the robot happy by touching the logo again, but again it will be sad because the temperature is still high. Okay, other than this, we will work with the sound sensor. Notice here, if we make a clap or a loud sound, the robot will move forward. See? Yeah. Now we are working with the light sensor. See, the stronger light we put on the microbit, it will move backward. You see? Yeah, this is regarding the light sensor. A button I just mentioned, it will play a music, and the potentiometer will control the sound volume. Okay, now we reduce the sound, reduce it and increase it. Okay, B button, what B button will do? Notice we will change the color of the LED REKA bit randomly. Okay, whenever we press, the color will be changed, and this is something cool also. There is one more thing after this. Let's see. Yeah. See now, if like we want to put the robot on the sleep mode, okay, we will make the robot lay down, okay, and then the LED will turn off, the eyebrow will go to the default position, and the screen will be cleared. Okay, so let's see what's gonna happen if we use this sensor. See, it switch off to the sleep mode. Okay, this is pretty much our robot. It's really cool, really awesome. Okay, uh, in today's webinar, okay, since we have like not too much time, we will focus mainly on how to program the robot, okay? How to program the LED, the potentiometer, the DC motor, and servo motor. But once it comes to assembly the part together with the cardboard, with the body and the components we have, uh, we will not have much time, but we will upload to you like in 1 or 2 days, okay? A video tutorial explaining details how to do all this, okay? But today we will focus and explain in details how to program all these sensors and components, okay? So any question before we like continue? Anyone? Or shall we continue with the tools and the components we need? If there is nothing, I will continue with the tools and components. Okay, what we need in order to make this robot? For the tools, it's really like simple stuff. We need a cardboard, as usual, okay? And we need a hot glue gun, scissor to cut the cardboard, cable ties to fix the REKA bit, okay? And we need a caster wheel, breadboard, okay? And I will explain to you why we need a breadboard in this case. For the components, we need REKA bit, okay, with microbit V2. Notice here we need V2 microbit because in V2 we have the sound sensor and also we have the touch sensor, okay? And this is cannot be found on the V1, okay? I just want to make this clear to you. Also, we need a servo motor, DC motor plus wheels attached to it, LED, potentiometer, and battery holder. Okay, so now let's start by showing you how to work with the external LED or REKA bit. And in my case, we will need a breadboard, okay, like this one, to for two reasons. Like we can connect the LED directly to the REKA bit, okay, but we are going to use the breadboard for two reasons. First thing, because you want to make the connection easily between the REKA bit and the LED, okay? And this is what the breadboard make. It make the connection easily between the components. And also, we need a space between the eyes, okay, or the robot. So in my case, in this project, we will use a breadboard. And if you like not familiar with using the breadboard, let me explain to you how does that work. It's really easy, nothing to worry about. Notice here like we have negative and positive lines, okay? And these holes, okay, whatever we connected here, all these lines will be connected together, okay? So if we connect one wire here and another wire here, another wire there, okay, it will be connected together horizontally, okay? All these holes will be connected together, okay? While in the other side over here, the opposite will happen. The dots or the holes will be connected together vertically, okay? So how to make the connection between the LED and the REKA bit? It's really easy. Let me show you. As you notice here, for this LED, we have two legs, okay? There is a long and short leg, okay? The long leg, okay, will be the positive, will be the anode. It will be connected to the output pin, okay, which is it, this one and this one in this case. And the short leg, okay, will be connected to the ground pin, okay, to make the whole circuit. So notice here, we have long and short leg, okay. This is the long one and this is the short one. The short one is goes to the resistor, and the resistor take the mission to transfer that leg to the ground pin, okay, over there. Notice we have the ground going here to the resistor, and then the resistor like attached to the short leg to the negative pin or negative leg, and on the pin outward pin, it's connected to the long leg, okay, to the positive leg. This way, like the connection is made easily with the breadboard, same idea is applied to the other LED. Okay, we have negative pin or negative leg with the positive leg. We make the connection. Okay, this one goes with the ground. Okay, this way, and P0 is connected to the long leg. Okay, so we can control the LED. We can decide which one we can turn on. Is it the red LED or is it the green one? Okay, so let me show you the connection. Okay, here, uh, Adrian, then you like show my screen. Okay, here again, like I already labeled the my breadboard to you to show you how the connection goes. You see the blue line over here. Whatever we connect over there, it will be connected together. Okay, and on the red line over here, whatever we connect on these dots, it will be connected together. So let's work with the green LED. See, we have a long and short leg. Okay, I will connect the long leg with the positive pin and the short leg with the negative pin. Again, the short leg will go with the resistor, and the resistor will take its place to the ground pin. Okay, so let me make the connection. Here we go. Can you see it? And also, let me connect the ground wire. Okay, in a moment I will connect this one to the REKA bit. Okay, but bear with me. See, the ground wire will go to the ground pin on REKA bit, which is it connected also to the resistor. And I will connect this one to the output pin on REKA bit, and it will go over here. Okay, and here, same line. This way we can make the connection easily with the REKA bit. Same goes with the other LED. Let me connect it. Okay, short leg, long leg. Okay, the resistor is already connected to the blue line. Okay, which is it will be connected to the ground. Okay, with one wire, and I will choose this white wire. Okay, to connect the output leg. Okay, to the REKA bit. Okay, see, now the connection is ready. We just left with connecting these wires. Okay, the male wires to the female wires we have on REKA bit. Here I have the REKA bit. Let me bring the groove port, groove wires. Okay, here it is. I will work with the first groove port. Okay, and I will take the the black female wire. Okay, and connect it to the ground one, the black one I have here. And I will take the white one that connected to the red LED and connected to the white female wire, which is connected to P1. And the green LED will be connected to the yellow female wire. In this case, it's P0. Now the connection is ready. Okay, now we are just left with programming these pins. It's really easy. I will show you how that works. So before we proceed, if there's any questions, please don't hesitate to ask. Let me show you how the program works. Okay, we will make or we will open make code editor. Okay, and I will deal with the buttons to control the LED. I will drag a button and I will click on this one, go all the way down to pins, and we will drag this block, digital write pin, and we choose what pin we have on the REKA bit. We are, in this case, we are dealing with pin 1 and pin 0. Okay, so leave this one as it is. This one will be pin 1, and it's to the low voltage now. Now a button will turn off the LED. Okay, So I will duplicate this one and we will work with the B button. What B button can do? It will give a high voltage to the both of the LED. Okay, so we'll make the value 1. And now the code is ready. A button will switch off the LED, B button will turn on the LED. So let's have a look. Now I'm programming the microbit. Give it a second. Please guys, if you have any questions, ask, okay? Okay, A button switching off, B button turning on the LED. As simple as that, really simple, okay? A switch off, B switching on the LED. I hope that was clear for you. This way we can control the LED with REKA bit, okay? As I mentioned to you before, we have already like 2 LED or REKA bit itself, but maybe like you have some kind of project that you need to use external LED. This is the way of controlling the LED with REKA bit, okay? Great. Now let's go to the potentiometer, okay? Okay, if you understand how to work with the LED with Rekabit, potentiometer is much easier for you, okay? Because it's really like straightforward, really easy. The connection can be made. For the where is it? The potentiometer. Let's have it over here. Anyway, the potentiometer, the ground pin, okay, will go to the ground wire over here. Output, okay, we can choose either of pin 1 or pin 0. And the VCC, okay, will go to the 3 voltage pin, okay. So now I'm going to show you the connection, how that made. But yeah, here it is. This is the
Right.
potentiometer. Yeah, I found it, yeah.
Okay, great.
Yeah, right.
Oh,
It
all
was in the
right.
drawer, but suddenly, like, yeah, I lost it.
Yeah.
Anyway, this is the
Okay.
pins, okay, the legs of the potentiometer. I will connect it to the groove port, okay. It's really easy. Okay, let's come back over here. We will not be using the breadboard anymore. Here I have the wires, okay. We will only use 3 of them. The red one, okay, the power supply one, and have the ground one, and the one that will control the output, okay. So here I have the red wire, okay. It will go this way, and the black wire, okay, will go this way, and the output wire will go in the middle, okay. And this way the potentiometer is already connected to the REKA bit, okay. This way, 3 wires to the potentiometer. Okay, what we can do with the potentiometer? Many things, many things. One of the things we can do is controlling the sound level, okay. And also we can control the brightness of the REKA bit LED, and we can control the speed of the DC motor, okay. Many stuff we can do with the potentiometer. So in this case, let's start by showing you how to work with the, or how to control the brightness of the RGB LED or REKA bit. So you will not be using this anymore. We need the REKA bit extension. We will go here, okay, extension, or over there, both can do. We write REKA bit. Oops, yeah, this one. And once it's already added to to our page. It will be shown here. Okay, we click on it, and we want to work with the brightness of the RGB LED. Okay, so we take this one over here. We will set the color of the LED to be, let's say, blue. Okay, now you notice here the brightness is set to 25. We don't want that. We want to control it. We want to increase it and decrease it using the potentiometer. How to do this? Really easy. We will go through pen, okay, and we will drag this block, okay, over here. Notice here we will choose the pin that connected to the potentiometer, and in my case it's P1, okay. And also notice not all of the pin can read the analog sensors, okay. So you have only P0, P1, 2, 3, 4, and 10. The others can only write, okay. So bear in mind this one. So yeah, now let's control the brightness of the RGB, okay. Okay, see, yeah, now I will reduce and increase the brightness of the RGB. Yeah, see, increase, decrease. This is one of the cool things that the potentiometer can do. Okay, okay, now let me show you how this potentiometer also can control the sound volume. Okay, so in this case we will go through music, and we will start this melody and make it running forever in the background, and I will change or set the volume to be controlled using the the potentiometer same way. Okay, so let's download the code, and you will notice now the music will be played on the microbit. See, now it's high. I can reduce it. No sound. Sound is like a bit higher, more higher. Okay, again, this is one of the cool things that the potentiometer can do, and it's really easy to connect it to the REKA bit. Okay, guys, great. Now we just learned how to deal with the LED and the potentiometer. Let's see what else we have. Okay, controlling DC and servo motor. This one is really easy because REKA bit extension made everything easy for us. Okay, all what we have to do is connect the servo motor and the DC motor to REKA bit, and then we will left with the programming part, which it will be like really easy for us. Okay, so let's start by connecting the components. Okay, okay, here I have a DC motor, okay, that connected to a wheel, and also I have the servo motor, okay, over here, and yeah, it's attached to the eyebrow. Okay, so I will connect the servo motor to the first servo port over here, this way. Okay, servo port is connected to the first servo port, and for the DC motor we have two terminals. Okay, I will be use the first one to connect the DC wheel or DC motor. So sorry, okay, the black wire, okay, will go over here the black wire. Okay, we'll go over here. Please, guys, if you have any questions, do ask us. Okay, now I will show you how to program the servo motor and DC motor, okay, in one time. I already explained this step, okay, in the previous webinar, but it's okay, we can do this again. So again, back to the make code editor. uh, we will control the motor and the servo motor using REKA bit extension. As I mentioned to you, it's make everything easy for us. We have this block, okay, it will control the DC motor, okay, and I will drag this block also, which can control the servo motor, and then I will make a delay for 2 seconds. Okay, again I will take this block, duplicate it, but this time I want it to move backward. Okay, I want to show you the difference, and again I will take this block of the servo, and I want its angle to be 123. Okay, and again I will need the delay to notice the difference. Okay, so yeah, let's program the microbit and see how that works. Okay, okay, see now, this is the DC motor. For 2 seconds it's moving forwards, and then it goes backwards. Okay, and for the servo motor, yeah, it can change its angle from 90 to 123. Okay, so yeah, it's really easy to control the DC motor and the servo motor with the REKA bit. Okay guys, I think now we left with programming the main components that can work with the robot. Okay, now we are left with the last one, okay, which is it controlling the sensors, okay, on microbit itself. Any questions
Okay,
before we?
all right. Yeah, before we continue to the next session, I think we have a few questions.
Okay.
Let's go through one by one.
Okay.
All right, this is from Ober. This is for the first project that you did just now. What happens
Okay.
if we connect the ground to anode of the LED instead?
I believe it will not work. Usually, like the anode will work with the with the uh, with the positive, with the input and output pin, and the cathode is always working with the ground.
Yeah. Yeah. So if you
The
go
circuit, yeah,
opposite,
will not.
it
Yeah,
won't work. All right.
exactly.
Okay. And then and the next question here, what difference is microbit V1 and V2? I think a lot of people are also curious
Uh-huh.
if these are can they be used on the REKA bit?
Okay, both of them can be used on Rekabit. There's no problem with that. But the difference between microbit V1 and V2 is that V2 have more features. One of the features it has a sound sensor, okay, that cannot be found on the V1, and also we have the touch sensor over here on the logo, okay. And
Yeah.
if we notice here, if we come to the make code editor, okay, if we go to input, okay, and go all the way down, you will have some blocks that only made for V2. It's for the logo and the sound level, okay. The rest can be deal with V1 just fine.
Yeah. So
Yeah,
V1 still works. It's just that lesser features compared to
yeah,
V2.
yeah.
Right. Okay.
But both of them working just fine with Reka base.
Okay. All right.
Yeah.
All right. Thanks for the question. I think there's this one more. This
Uh-huh.
one This one maybe I can take it. Right?
Okay.
Is it easy for standard 4 students? Standard 4 is primary school students are
Uh-huh.
10 years old.
Yeah.
I would say students at 10 years old, they can start with Scratch and then microbit. And then REKA bit is like the next level of microbit. It's like an extension. After they learn the basics on microbit, then they can move on to REKA bit to learn DC
Yeah.
moto, servo moto, right? More stuff to learn. Okay, so
Yeah.
I hope I answered your question over there. Um, okay, guys, if you have more questions, do drop your questions in the comment section, and then Ahmed will answer your questions in the next part of the break now. All right,
Yeah.
I'll give you back. All right, you can continue the session. Thanks.
O- Okay, guys. So again, to what we have here. Just now, I show you how to work with the LED, potentiometer, DC motor, and servo motor. Okay. Now we have these components. We want it to be reacting to the sensors we have on microbit. Again, due to the short time of the webinar, I will show you the whole code of the robot, okay, of the interactive robot. But no worries if I go through it too fast. Don't worry, like we will upload later, like a video tutorial that explain in details the program code, okay, and how to make the cardboard and everything in details. But now I will give you an idea how to activate these sensors on the microbit and how to make it, or how to make the components we have on REKA react to the sensors we have on microbit. Okay, so I have the code over here. Oops, give me a second. I will come with the code in a while. Where is it? Yeah. So this is the code we have. Okay, it's a bit messy, I know, but no worries. I will explain to you how that will work. Okay, in this project, we will deal with some function, okay, to make the code easier for us to understand. I will go through it one by one, and I hope like you get the idea. First of all, we have temperature sensor, touch sensor, and light sensor, okay? And if we take a look on these functions, okay, let me explain to you the sound sensor, okay? So if we detect like a high sound or like a loud sound, okay, the following will happen. We will have the bar graph, okay, it will plot the sound level, okay, and the motors will move forward to us, and the LED, okay, on the REKA bit, it will be changed to green color, and then we will have a delay for 1 second, and we will break the motor, and everything will be reset, okay, we will clear the screen. This is in case of the sound like too high. This is what will happen, okay. Then for the light sensor, if the light is so high, okay, the motors will move backward, okay, at the speed of the light, okay. The more light we have, the faster, or the faster the robot will move backward, okay. And the LED will be changed to the red color. Again, we will have a delay for half second. After this, the motors will be break, will stop, and we will change, or we will clear the screen. Temperature sensor. If the temperature is so high, higher than the limit we set, we will call a set function. What is set function? I will show you that in a moment. And it will show this set face, set icon. Also, we will show the temperature value on microbit screen. And we will have a delay for 3 seconds. Okay? So, what is set function? Let me go through this. Here I have 3 functions: sad, happy, sleep. Let's start with sad. Okay, if the robot is sad, okay, we will play a sad sound, okay, the servo motor that controlling the eyebrow, okay, it will go down this way. The pins that connected to the red LED, it will be turned on because it's set. So we will have a red LED, and the green one will be turned off. This this method I just show you, okay, on how to work with the LED. And in case the robot is happy, we will have a happy function, okay, that will produce a happy sound. The servo motors will go upward, okay, be happy, and the green LED will be turned on, okay. And if the robot is laid down on its back, it will produce a yawn sound, okay. The screen will be cleared. The servo motors will go to its default position, and all the LED will be turned off, and all the RGB pixels will be turned off also. Okay, so let's get back to forever loop. Now we can control the volume using the potentiometer. I just show you how to do that. Same way, and then see how the code now has become much easier for us. Now, if the light level is higher than 70, okay, we will call the light sensor over there just now. So no need to drag all these blocks over there. It's much easier to make it separately, okay? So if the light sensor is too high, we will call that function. And if the sound level is high too, over than 100, we will call the sound sensor, okay? The robot will react to the sound sensor. Here we can set the temperature limit. Just now I make it 37. You can adjust that to whatever value you want. So whenever the temperature exceeds that limit, okay, we will call the temperature sensor we have. Okay. Uh, okay. Other than this, here we have once we touch the logo, okay, on logo touch, we will call the happy function. Okay, it will show a happy face. And if we make a long press on the logo, we will call the sad function. Okay, and it will come with it all the sound, the red LED, all this stuff that been included in the sad function. Okay, screen up. Okay, here we have many stuff to do. Either we can make the screen up, make the robot standing. Okay, we can do, like choose whatever we like. But in my case, if we make the robot lying on its back and the screen is facing upward, this is what happen. We will call the sleep function. I just show it to you just now, and then we will have a delay and we'll stop all the sounds. Okay. Last two things, we will deal with the buttons. If we click A button, we will play a melody. Okay, this one. And if we click B button, we will turn on the RGB LED, okay, on the REKA bit with the random colors, okay, like yeah, we have random colors, like yeah, we just click, it can show us like a lot of many colors, okay. This is pretty much the code. If I go through it fastly, like if you are missing some points, like not clear, no worries, I will explain that in details in my upcoming video tutorial, which is it. I will go in details through the program part, and also I will show you how to combine the components with the cardboard and attach it together to make such a robot. So, any question, guys, regarding the code? Once we upload the video later on, also we will share it in our Telegram group. So, yeah, join us please in there. Any question regarding the code or how to deal with the LED, potentiometer? Anything is not clear to you? I think this is pretty much our webinar. We just finished. Okay.
Yeah.
Adrian, you may join us. Yeah.
Yes. Yeah, I have a very simple question.
Uh-huh.
All right. This is to follow up with the previous question about
Okay.
is this that easy for standard four?
Uh-huh.
If it's not that easy for 10 years old, what age do you think this project is suitable for?
Uh, I think it's easy. I think like from age 9 and above, they can understand. They can do it. Yeah.
Right?
It's
But the
uh-huh.
hardest part is still combining everything together, right?
All right. Right. Right.
Yeah.
Yeah. It's like need supervision from parents. Right.
Yeah.
So I would say 13 can be
So you would
13, 14
recommend, okay.
in
So
that range of age. Yeah. It's true. Once we talk about combining the components with the cardboard, yeah, it
it
might be
becomes
like,
harder,
yeah.
right?
But
But
once we talk, uh
if it's just like LEDs and DC motor, then 9 years old, they're
yeah,
okay.
that will be fine. Yeah. Once we come to the combining the components with the cardboard, yeah, I think this is the tricky part, the difficult part. Other
Okay.
than this, yeah, the project is easy. Yeah.
Yeah. Yeah, I would think the same as well, because
Yeah.
it may look intimidating when the code is like, oh, so big,
Yeah. It's
unless
easy.
they follow, right?
Yeah.
I think we have one question here.
Uh-huh.
Okay, is the code case sensitive?
I'm
Um,
not sure if I
s-
get the question.
so far the block-based program, there's no need to type any alphabets, right? We don't need to type any
No,
alphabets,
no,
if
no.
I can. Only just numbers, one and zeros.
Yeah.
So it's not text-based. But of course you can use text-based in make code as well. Like you can use JavaScript to program a microbit. And if you go to that level, then yes, the syntax have to be accurate, right? You can't just simply type your syntax anymore. But for the block-based programming, it's very straightforward, right? Just drag and
Yeah.
drop.
Yeah.
So give it a try. It's makecode.com, makecode.org,
Make
right?
code. Yeah.
.org,
Yeah.
right? Yeah.
Okay. Make code dot microbit dot org.
Microbit.org. Okay.
Yeah.
Yeah. So, okay, guys, if you have more questions, we still have 10 more minutes. You can still drop your questions in the comment section. We will still be here until 9 o'clock. All right. And let me see. Okay, a few things that we would like to share. All right.
Uh-huh.
Before we proceed to the next part of this session. So, we actually have this community going on. It's mainly for juniors, students, right? Not limited to just Malaysians. We are open to different countries. Wherever you are, we welcome you to join our Telegram group. Right, it's called Junior Makers Assemble. It's meant for juniors students who are keen in learning STEM or electronics, or these fundamental subjects, right?
Yeah.
The microbit and also programming. So we have a lot of engineers in the group, some experts as well, but we try to keep the conversation light, make it easy so that you don't feel intimidated, you don't feel scared. Um, so we welcome you to join. You can scan the link here. And I believe some of you are here you're waiting for the e-certificate. We will also be sharing the link by the end of this session. Very soon, very soon. Okay, stay with us, and uh, keep the interaction going. If you have more questions, go ahead, ask the questions. But later on in this session, we will share a feedback form, and you are welcome to fill in the feedback form, and you will be able to receive the e-certificate through your email. Okay. So in our next week's session, we will be sharing about 3D printing. I will be there as well, and we will talk more on the things you will need to know before you get a 3D printer, right? The basics of 3D printing. Okay, I believe some of you are just here. Like, if you just join right now, it's okay. You can still rewatch this session. It's a recorded session. You can go to Cytron Tech YouTube channel. Okay, find out our webinar live series. So we every week, every Saturday, we have this Cytron webinar series. Uh, Normally we do it in the morning, but today we do it in the evening. So I believe some of you are new to this series. You have never seen this series before, but it's been
Yeah.
going on for like this is the 21st series already. So check out our YouTube channel. We have a lot of this series. You can go and watch whichever topic that you find interesting, you're interested in. Go ahead and watch it. Join our Telegram group. Ask us questions. We are there. Alhamed is there. He can
Yeah.
also answer your questions on Rekabit over there. And you
Yeah.
mentioned that you will be sharing the tutorial, right?
Yeah. We will share
Okay.
that on the Cytron YouTube channel, okay? The video tutorial. And also we will share that on the junior Telegram group. So yeah, you may join us using
Yeah.
the link.
Okay. I guess we can. Let me. All right. And then I'm gonna share
Uh-huh.
one link. Okay. So I'm gonna share a few links. All right. So to join our Telegram group, here is the link, and here is the link for the feedback. We appreciate your feedback. Drop us your feedback. Let us know what you think about today's session. Let us know what you want to see in our future session. You can even tell us what's your best time to attend a session, a webinar session. We will try to keep it casual, all right? So go to this link, fill in the detail, and you will also receive the e-certificate after you fill in the form. Right, so make sure that you fill in the form with the correct detail. Your name is correct, no typo, it's correct email, right? Don't if you give a wrong email, you won't receive a certificate. If you give a wrong name, then your certificate will be given a wrong name. So make sure you double check before you submit your form. Okay, anything else you want to add on, Ahmed?
No, I'm okay. Thank you so much, guys, for joining us. Yeah.
Yeah, thank
We
you
hope
for
that we meet you
joining.
again in our, in our upcoming webinar. And again, if you have any question regarding Recabit, please join us on our Telegram group. We will be happy answering all your questions.
Yeah. And we
Yeah.
also hope we didn't interrupt your dinner, or this is a good show for you to have dinner and watch at the same time.
Yeah.
Okay, I think we have questions here.
Uh huh.
Okay, I think this question is it's something that you didn't cover just now, but
Uh huh.
something that we can highlight and we can answer later on as well. Can
PIR
PIR
motion.
sensor, motion sensor be attached to Rekabi, and how to code the PIR motion sensor? Um, Technically, yes, it should work. All right. I don't think we have tried before, but it should work. PIR sensor is able to provide digital signals, right? One and zero, whether it detects motion or no. So by reading your digital input, you should be able to get one or zero, and by supplying the correct voltage. So in Rekabit, it's only supplying 3.3 volts, right?
Yeah.
Yeah, 3.3 volts. So it depends on whether your PIR sensor needs 5 volt or 3.3 volts. You need to provide the correct supply, and then just measure the digital, use digital read, measure the pin, and you'll be able to get the motion from your PIR sensor. I think that's how it works, unless there's a trigger pin and there's a receiving pin, right? But again, join our Telegram group, ask us over there straight away, and then we will test it out immediately and give you a more direct answer over there.
Yeah.
Okay? Thanks for the question. Okay. All right. So if there's no more question, I believe we are gonna end our session like around 4 minutes earlier. And if you still have more questions, join us in our Telegram group. We will see you there. And yep, I will see you guys next week. And Alhamed will also be seeing you very soon in his YouTube
Yeah.
tutorial. So
Yeah.
catch us. All right. And thank you for joining us today. Thanks, guys. Thank
Thank you,
you.
guys. Bye bye.
Thanks,
Have a
Alhamed.
good night.
Thanks. Good
Thank you,
night.
Adrian.
Thank you.